This video is about the particle model for the three states of matter. First, let's look at the properties of matter in the three states. There are three states. First one, solid. Second one, liquid. Last one, gas. Can you name some examples of solids, liquids, and gases around you? Let's watch the video first.
Place a wooden block in a beaker. Does it take the shape of the beaker?
The meaning of taking or take the shape of the beaker means that does this wooden block change its shape and then fill in this beaker.
Take out the wooden block and place it on the bench. Then press it with your finger. Can you compress it? Half fill a beaker with water. Pour the water into a conical flask. What happens to the shape of the water?
Just for your reference, the shape of water is like this, okay, before you put it in a conical flask.
Half fill a syringe with water. Block the tip of the syringe with your finger and try to compress the water inside by pushing the plunger.
Okay, the meaning here will be, can you try to push it? Okay, this one will change.
Can you compress the water? Inflate a balloon with air until it is about the size of a fist. Then tie its neck with a rubber band. Try to squeeze the air inside the balloon. What happens to the shape of the air?
Okay, when you press it, you can see this is elastic and it will just push inward and then the shape will probably change. Okay, the shape of the balloon will change. So does the shape of the air.
Half fill a syringe with air. Block the tip of the syringe with your finger and try to compress the air inside by pushing the plunger. Can you compress the air?
Okay, the meaning here will be just like when you press it, it will move inward and then will rebound. That is why the shape here will change. Okay, the shape here will change, and that means you can compress the air.
By pushing the
Let's see here
plunger.
together.
Can
Okay,
you
the shape
compress
can
the
change.
air?
The shape can change. Now we will check the answer together. Okay, you cannot compress it for solid. For liquid, it will take up the shape of the conical flask. And when you do it, you cannot compress the water. When you squeeze it, you can change the shape of the air. When you do this, you can compress the air. So this is the summary for true. You have to know the result. This one, solid. It has a fixed shape, cannot be compressed. For liquid, does not have a fixed shape and cannot be compressed. For gas, it does not have a fixed shape and it can be compressed. So from experiment 6.4, first one, solid, have a fixed volume it cannot be compressed, and it have a fixed shape. For liquid, it has a fixed volume, it cannot be compressed, it has no fixed shape, but take on the shapes of the containers. Last one, for gases, it has no fixed volume. It can be compressed, so the shape is not fixed. It takes on the shape of their containers. This is the key point. So for this one, you're going to check your understanding. Just put down the answer on a paper and then you check it. This will be gases because it can be compressed. For those that cannot be compressed but with a fixed shape, this is a solid. And the last one will be liquids. Then it is about the particle model. To begin with, I would like to play the video first. This is about a simulation. This is a simulation of solid, liquid, and gas in particle model. This is solid. The particles are vibrating about a fixed position. And this is water, and this is the model of liquid. The particles are moving around each other, and they are packed irregularly. This is air, and the particles are in the gaseous state. The particles are moving freely. Now, so when you compare it, you may hear the answer in the video. Similarities in solid and liquid, they are close together, but differences will be the particles in a solid are arranged regularly, while the particles in a liquid are arranged irregularly. And then for this one, particles in a liquid are close together, while particles in a gas are far apart. Last one, okay, for solid, liquid, and gas. Okay, for solid, they can only vibrate about fixed position. The particles in a liquid can move around each other. And for particles in a gas, they can move freely. Okay, the key idea is freely here. Okay, for solid, that will be fixed positions and also vibrate. So how do they describe the arrangement and movement of particles? Scientists have proposed a particle model based on the particle theory. It helps describe the arrangements and movements of the particles in solid, liquids, and gases. So just like what you can see in the simulation, the particles are close together and arranged regularly, and they cannot move from one position to another, but can only vibrate about fixed positions. And for liquid, the particles are close together but arranged irregularly, okay, and they can move around each other like this, just like what you can see in the simulation. And for gas, the particles are far apart. They can move freely in all directions. Okay, you cannot predict the direction of the particles. So the key point is scientists use the particle model to describe the arrangements and movements of particles in the free states of matter. Okay, the last part of this video is to explain the properties of matter in the free states. We will use the particle model to explain the properties of solids, liquids, and gases. First, let's look at this one, solid. Does it have a fixed shape? Yes, a solid has a fixed shape because its particles cannot move from one position to another. Can it be compressed? No, because the particles are close together already. Okay, so you cannot press it, you cannot change the space between the particles. Okay, does it have a fixed shape for liquid? No, because the particles can move around each other. Okay, how about this one? Can it be compressed? No, because the particles are close together. For gas, does it have a fixed shape? No, again, because the particles are moving freely in all directions. How about this one? Can it be compressed? Of course, this time it will be a yes, because the particles are far apart, so you can make the spaces smaller. Okay, this is the end of the teaching part. So the last one will be the checkpoint for true. Just try to answer the question before you click on it. Okay, I will give you some time here. Okay, so first one, true or false? Okay, particles in solids still, it is not correct because they are vibrating about a fixed position. The particles in liquid can move freely in all directions. Is not correct. That should be gases. Liquid water and water vapor, both of them are water actually. One of it will be liquid, one of it will be gases. So they are the same particle. Gases can be compressed because their particles are far apart. That is also correct. So now this one, I guess you just have to take out a paper and try to draw it. Okay. You can count it. The number of particles and the size of the particles should not change. What should be changing or what have changed will be the spaces between the particles.